So next up, we have James Gollan from Confluent. So James has been working with open source software for 20 years. For the last 4 years, he has been a solutions engineer for Confluent and has a particular interest in the power of stream processing to transform and enrich data in real time. So James is doing a thought leadership session on leveraging streaming data in real time to build trust and enhance customer experience. So welcome, James.
Just give me one moment. I'll be plugging in my laptop and we'll be swapping over. Right, Fantastic. Well, thank you all for your time today, attending. I'm going to be talking about building trust with citizens and customers using real-time streaming data, and there's quite a lot in there, and there will be quite a lot of topics that we move through pretty quickly. But hopefully, by the end, you get an understanding of how streaming data and real-time data can be used for a variety of different reasons to improve kind of like the outcomes for citizens and their experience in interacting with government. So I start with this slide, and I start by doing that. Okay, I think that will be better. And so there's like a sense of sort of danger here. There's an 8-lane highway with a young child at a crossing, considering when to cross. And pause for effect, and then we bring in the sort of like the question. And the question is, would you blindly cross a street with traffic information that's 5 minutes old? And I think, hopefully, everybody's answer is no to that question. And then so we start actually playing with the timeframes. What about 1 minute? Still, clearly a no. And you end up at maybe around a second where you would feel that that information was actually accurate enough for you to make a decision. And I think that's a really sort of like interesting way of understanding the value of real-time data in a lot of situations. And so I'm going to make a fairly uncontroversial statement here, that real-time data beats slow data. It's not necessarily kind of like always better, but if you have the choice between getting the data in real time or getting it on a delay, you're always going to choose real time, all other things being equal. And so we see across governments a lot of use cases that are enabled by actually accessing that data in real time. And I'm not going to go through each of these, like I'm too empathetic for that, but I can actually sort of like, say that every one of the use cases on this slide is something that we're doing with a government or multiple governments around the world. And you can see sort of like each one of these is kind of like really reliant on real-time data to actually be effective. And so take public transportation as an example. Buses are emitting telemetry data saying where they are. That may be updated every 5, 10, 30 seconds. That data is not very useful in 5 minutes because you've missed the bus. And so those kinds of shifting and thinking about how data is used and how it's valued are really important. And it's not just us, sorry for the terrible quality of the actual image, but this is Forrester. And Forrester have kind of like given information a half-life. This idea that real-time data has a lot of value, but it decays very quickly. And so if you can't action that data in the first few seconds, you start to lose a dramatic amount of value. And this is relevant when we're talking about citizen experience, because quite often, whenever you want to make an intelligent decision based on the context of the user, you need to be able to action that in the moment. So you're actually offering the best next action to the citizen as they move through the system. Another kind of just interesting report from McKinsey actually said that kind of like one of the factors for success in digital transformation, one of the characteristics was successful transformations used 1.5 times more real-time data than unsuccessful. Now, correlation, causation, sure, but it's just an interesting sort of like way of thinking about real-time data and the success of projects. So, I'm guessing there's a lot of data analysts in the room, and you're used to working with batch data. And you may at this point be sort of thinking, yeah, I can see the application of real-time data being important in certain situations. But that's not me, because I'm working with big data sets that are old, and they don't have to be timely. They don't have to be down to the second. And so you may be thinking that stream processing, again, a great technology, but not the problem I'm trying to solve. Well, the problem I'm guessing you are trying to solve can be as transformative as the real-time aspect of event streaming, and that's data consistency. So I'm guessing that a lot of you have struggled with inconsistent data sets, and we were at a dinner last night and somebody was saying sort of like everybody builds their own reports for this meeting and everybody's numbers are different. And it's because we have this inconsistency and we have a sort of a failure in understanding the data it is that we're trying to process. So having said that, and bringing this back to sort of like citizen trust, there's this, this is from the UNDP policy, so it's not about the Australian government, but there's a sort of uncertainty regarding the conduct of a government. And trust is this belief that we will use the data in a way that is kind of like, that leads to sort of positive, meets these positive expectations, right? And so bringing that into the data and digital government strategy, we sort of like, we see this statement. And so this is from one of the 5 pillars, the trusted and secure. And one of the first things they say is around building and maintaining trust. And it makes the point that essentially, if we do this well and we meet expectations, we start building trust. And so if a customer's experience with government is good and continues to be good, and the government treats their data and stores their data and kind of like protects their data in the way that we expect, this starts to build trust. The interesting thing is kind of like when they fail, there's an erosion of trust, but maybe more importantly, there's potential impacts on safety and well-being. And so that's a really sort of like important aspect of building sort of trusted and secure relationships based on trusted and secure data. Another sort of like point coming out of that data strategy was deploy scalable and secure architecture. And it just makes the point that, you know, governments are built on legacy systems, and they're built on, they weren't legacy when we bought them. They're legacy because they're older, and they're hard to get off, because a lot of time, investment, and data actually exists inside of them. And so looking into the future, and of course this is something you would say looking into the future, we're trying to address the problem kind of like at a more holistic level, and in a way that's going to meet sort of like more than just an individual use case's needs, because a lot of this kind of technology is purchased to solve a particular use case, and quite often it is actually the best choice for that individual use case. But it doesn't look to the future. What happens when the next use case comes along? How do I get reuse out of that? This one I really like. Okay, so this is about delivering for all people in business. That's the section of the data strategy. And this talks about maximising value from data. And it gets into the areas of data governance, which we're going to touch on. What I really like about this is data governance is quite often seen as protecting data and restricting access. And it's certainly a primary goal is that. But by applying governance, we start to understand our data better. And that allows us to actually open up the data that doesn't contain sensitive information, that can be shared. And so this idea of moving away from the risk-averse approach, which is, I don't really understand my data, therefore I'm not going to share it, into I'm going to start to understand my data better, and then I'm going to understand exactly how it can be shared. I think that's a really sort of like important and a really sort of forward-looking statement. And then particularly important in government and relating to the last talk is this idea of tell us once. One of the quickest ways of eroding user experience is like people are on mobiles filling out forms, and if you ask them to fill out the same form 2 or 3 times, that experience erodes all of that hard work and trust that is built over time. And so this idea that tell us once and then we will actually understand that data and understand your context is really important. It's also really hard. Like, I'm sure everybody in the room knows how hard that is. But we do have a case study coming up of kind of like a state department who is actually using a single view of customer or citizen to actually implement this tell us once. So that was kind of like a bit about real time. It was a bit about sort of like data strategy and where sort of like, you know, how sharing and trust is built. But Confluent as a company, we essentially work with what we call event streaming. And so the question might come, well, how does this all fit in? And how does this like eventually tie into your concerns, which are probably on that data analytics side? And so I'm just going to talk a little bit about how event streaming works. And I'm going to put up a picture which, I mean, it's not your data architecture, but it is your data architecture. But well, it's not, it might be. Every data architecture in every organisation eventually gets to this state where there's just a big data mess. And again, it normally is just a series of decisions that made sense on their own at the time, but has just led us into a problematic state. And one of the things that we see across not just government, but also commercial, is all of these systems that need to integrate, and the easiest approach, as I said, at the time for that one solution is to just connect those two systems together. These systems, and over dinner we were talking, these systems quite often might be spreadsheets on somebody's computer. They might be actually a SaaS service. They might be a database that is a system of record for some citizen information. But this is a very, very kind of common pattern. So how did we get here? Well, we make the observation that there is kind of like these two estates in data. There's the operational estate. The operational state is where transactions are being created, users are interacting and submitting forms, things are happening. And so these are operational systems. And on the right-hand side, we see the analytical estate. And the analytical estate is where we actually take all of the data that's generated in the operational estate and we turn it into insights. So we run reports, etc. And historically, what we've seen is the complexity of connections in the operational state increase, and that all gets pushed into a data warehouse. But this was sort of like a view maybe from a few years ago, but these days it's starting to look a lot more like this, where we're getting more and more operational systems, more and more data sources, things like spreadsheets that contain absolutely critical reference data that doesn't change very often, down to sort of like the real-time systems. And we're actually pushing these into more than just one data warehouse. There's a data lake. And we're actually trying to reason about all of this and do this kind of like, do this in sort of like as close to real time as possible. And what we end up with is a very sort of confusing mess of transformations that happen. And this is why my report looks different to your report in the meeting. It's because I've made assumptions about the data, I've joined the data in a particular way, and I've missed something, or you've missed something in the way that data is actually meant to be interpreted. And so this, if anybody, and by the way, if anybody's ever been to a vendor presentation, we always spell out the mess, and you'll probably know that the next slide is about cleaning that mess up. And the reason I can stand up here and do this sort of like hand on heart is because there is actually, it's very different. You could have seen this slide when you were looking at ESBs. It's the same idea. What's changed is the underlying technology of event streaming. And that's why this is different to kind of like other approaches that you've taken. And I won't be going into all of those differences. I don't have time. But it actually is a fundamentally, and we've got a booth here, so if you want to talk about kind of like those differences, more than happy to talk about that. So this is the sort of like the beginning. So on the left-hand side, we have the operational systems, and this really is where our data is coming from at the end of the day. And what we try to do is we don't think about analytical data or operational data, we just think about data. But that data is typically being generated by observations, interactions, kind of like, you know, real-time systems, SaaS systems. These are the data silos that you have, and sometimes you want access to data that's in one, but you don't have, that's not available to you. In the past, as I said, we would create point-to-point connections between these systems, but they're kind of brittle and hard. Using event streaming, we actually connect to all of these systems in a sort of like real-time way. So what that means is, whenever there's a change in a system, in the past, what you might have done is every hour you would query that system to say, oh, has the customer's address changed? Most of the time it hadn't, because people don't move that often. In this system, we don't query that database to ask what's happened with the address. When the address changes in the database, it sends that as an event into the streaming system. And so that's why we can deliver these real-time and very efficiently, because we're not overburdening the systems that are already just trying to do their transactional thing. So getting that data in is one thing, but the next thing that you need to do typically is to process that data, because that data is coming across in a particular format. It may have domain-specific fields that you want to filter out before you share it. So processing can be from the very simple, just removing a couple of fields or even anonymizing some fields, to the much more complex where we're joining across tables or even systems to get a unified view of a business object. Now, all of that's great, but it all has to come with governance. And so, especially in this sort of like the context of trust, governance is absolutely critical. We need to understand what data is in the system and how it can be used. Now, the interesting thing here is that the governance happens as soon as the data enters the stream. We kind of call that bottled at the source. This idea that you want to start governing and cleaning up that data as close to the ingress as possible, so you're not doing it in a data warehouse with people who actually don't understand the data in the way that it's meant to be understood. So that governance, critical. And by combining sort of this real-time data with processing and governance, we can move across to this idea of data products, which some of you may have heard about. Some of you may be familiar with this notion of data mesh. One of the sort of like 4 principles of data mesh was data as a product. And I think it's a really, really interesting one, because if you think about data, it's traditionally referred to as an asset. An asset, an asset, you're trying to acquire as much of an asset as possible, and you're trying to protect that asset. When you call data a product, it's a very different value statement around it, because a product is designed to be used, and a product has customers. And so we start focusing on the shape of that data, the reliability of the data, the SLAs behind the data, etc. So it's a really nice shift in thinking. Those data products are then consumed by other operational systems, but also analytics systems. And so we end up with this like pattern where we connect in real time as soon as something changes, we process in real time, and worth mentioning, real time for us, we're talking milliseconds. There are systems in finance that are nanoseconds, but like we're talking sort of sub-second end-to-end is kind of like a typical latency. It can change based on the use case. So that's kind of like how stream processing works, but I do want to take a step back and just think about these operational estates and the analytical estates, because again, a lot of this I imagine, well, I hope, is a little bit interesting, but it may not be sort of relevant to your day-to-day of working with data, or you may not think it's relevant. So 2 things are sort of emerging as kind of like standards around the operational estate and the analytical estates. First is Kafka. So Kafka is basically that stream when we're pulling that data in. And 2 of the key characteristics of Kafka which make it sort of perfect for this. One is incredibly high throughput. So it can actually process a huge amount of data. And that's why companies like Netflix and Uber and other large companies that are truly processing sort of megabytes, gigabytes per second, they use Kafka. And the other thing is latency. It's very low latency, which means that we can actually get the data where we need it very quickly, even at these high scales. So that's sort of emerging on the operational estate. On the analytics estate, all of the data that's being collected in Kafka needs to be presented to your analytics engines. And a format that is sort of like emerging as like the leader in this space is Apache Iceberg. So Iceberg is essentially a way of structuring data on a disk and presenting it in a way that can be queried by analytics engines in a sort of like a well sort of like accepted format. So what we're not doing is actually copying the data into the data warehouse and doing other things. We're just presenting that data in this way. So how do these two things join? And that's kind of like, again, there's something that Confluent are doing, which is to say that we are going to take all of that operational data that is being generated and being in real time, and we're going to expose that as Iceberg tables. What that means is you will be able to query that data from the analytics estate without doing any of the fragile data engineering where you're saying, okay, well, I need to pull that into the data warehouse. I don't really understand the schema, so I'm going to sort of like make some assumptions here. All of that is actually available in Kafka. We know the schema, we know the data format, and so we can actually make that accessible. And I think it's early days in terms of the impact this is going to have, but I actually think it's going to be quite a profound shift because suddenly your data warehouse is looking at real-time, up-to-date data. So key to this, and key to this trust conversation, is this idea of governance. And one of the kind of like concepts that you may have heard around is data contracts. And so that's basically saying, if I'm going to be consuming data and building an application or building analytics on top of data, I need to sort of like be convinced that the data is going to be presented and governed in a way that isn't going to break my downstream use cases. We've probably all seen cases where a change in schema in an upstream system that nobody even knew was connected breaks pipelines and stops your reports. So data contracts are key for actually understanding and governing this. And the way we sort of approach this at Confluent is through what we call stream governance. So remember, streams, all of these like changes that are coming across, and one of the characteristics of a stream is that it's unbounded, which means we always expect more data. You know, we always have the current data, but we expect there's going to be more data coming in. So governing that is slightly different to governing a static data set. The first thing is the stream catalog, which allows you to actually tag and organise data so that it's actually discoverable across the organisation and it's tagged in a meaningful way. The second thing, though, it becomes quite very interesting, I think, stream lineage. So when I look at a data product, and we just talked about the ability to create these data products, how do I know the provenance of that data? What systems are actually generating this data? And equally, where is this data going downstream? So stream lineage gives you that sort of like graph view of data flowing from those systems that we talked about integrating with, all the way through to being sunk into a data warehouse. And so you get a really good understanding of that lineage. And then finally, and probably most importantly, is stream quality. So stream quality is at the schema level. So as I'm sure you're all aware, data has a schema, and we agree to that schema, and that defines the data types that are going to be and the structure of the payload that we're sending across. Those schemas change over time. That's a fact, like that's just a fact of life. So it's really important that we actually put rules in place to say how we can evolve this schema. Because once we have that rule and those rules in place and enforced, we don't make breaking changes to downstream consumers. There will be changes, but the system won't allow a change that breaks that data contract. Now that's the structure of the actual payload, but there's also sort of like semantic meaning within those data fields. So stream quality allows you to define rules about what good data should look like and what to do if it doesn't match. Medicare number as an example. So if a field contains a Medicare number, there are rules, however many digits are in a anybody know? No. I'll say 12. If it doesn't match that pattern, then we actually push this into kind of like what we call a dead letter queue so that it can be monitored and corrected. The final thing in stream quality becomes really interesting because we can actually look at the schema, which says, and like a lot of data will have PII ratings or even PCI. We can actually tag those fields at the schema level, so we understand that when a message comes through, these fields are tagged with PCI, and attach that to policies for encryption. So those policies for encryption will mean that at the client side, data is always sent in an encrypted format for those fields based on that policy. And that can be really important if you're moving data into the cloud, but also if you want to share those data sets with people who don't have access, if you don't want them to have access to certain fields, those encryption keys become critical. Final thing, sort of like on the product side, before I just very quickly talk about a couple of use cases, and then how am I going for time? Right. Overtime? Oh, okay. Real-time data products. I am over time apparently, so what I'm going to do is talk one case study because I think it's particularly relevant, if that's all right. Yep, as it would be very quick. Service New South Wales. So anybody aware of sort of how Service New South Wales are implementing single view of customer? Anybody heard the, yeah? So Service New South Wales have ambitious plans. They have 70 different product teams working with over 200 partners, products, and they're implementing over 1,300 transaction types within the system. And this ties back into that tell me once, because Service New South Wales now know when you interact with Service New South Wales, whether you've applied for bushfire assistance or other aspects of the system. And so they can actually suggest, they might know you're a business person, you've got 2 kids, they can actually suggest services from the government that may be meaningful. So they're actually doing that currently on Confluent. Won't talk about the other 2 use cases. One was NASA, one was US citizenship. The one thing I'll just point out, Confluent, you may not realise this, we're available on-prem, so we can be in high-side, low-side environments. We're also available in cloud. And the big announcement we just made was our cloud is IRAP protected, certified to the IRAP protected level across all 3 cloud providers. So that's Amazon, AWS, and Google Cloud. So thank you. Sorry for going a little bit over time. I'll be here all conference.